Have you ever really thought about what's happening inside your phone when you tap on an app? I mean, it feels like straight up magic, right? But underneath that glass screen, there's this incredibly complex layered system. Today, we're going to pull back the curtain and explore the secret architecture of Android. You know the feeling. You tap an icon and boom, a whole world just opens up instantly. It seems so simple, but it's actually the result of this amazingly sophisticated structure. So let's break down exactly how your phone pulls off this incredible trick every single time. To get our heads around this, we're going to use a really simple analogy. I want you to think of the Android system as a house. It's built with different floors, right, from the foundation all the way up to the roof. And just like a real house, each floor has a very specific job that's essential for the whole thing to work. So before we start building our house, let's take a look at the blueprint. What's the fundamental design here that makes your phone, actually work? It's a lot like your own body, really. You have a brain, a heart, hands, and each part has its own job. Well, Android is built on 5 distinct layers. Each layer is a specialist, totally designed to handle its own specific tasks to keep everything running buttery smooth. Every good house needs a rock-solid foundation and a great set of tools, right? So let's start at the very bottom of our Android house and check out the first 2 most essential layers. All right, we are starting in the basement. This is layer 1, the Linux kernel. You can think of it as the building's head of security and its power manager all rolled into one. This is the absolute foundation that everything else is built on. Now, this layer has a massive amount of responsibility. It's the direct line to all the physical hardware. We're talking the touchscreen, the camera, the Wi-Fi chip, you name it. It's also the security chief, managing memory and making sure your battery doesn't die in an hour. And it's all built on the super powerful and proven Linux kernel. So that instant response you feel when your finger touches the screen, yep, you can thank the Linux kernel for that. Okay, moving up from the foundation, we find the native libraries. Now, if the kernel is the concrete foundation, these are the expert plumbers, electricians, and carpenters, the specialists who handle all the specific, really complex jobs. They're basically pre-built programs that do the real heavy lifting for your phone. And here's how that works in real life. When you tap to play a song, your phone calls on the media library. When you open up a photo, the image library takes over. Need to save a message? The SQLite database steps right in. Every single complex task has its own dedicated expert, ready to go at a moment's notice. Okay, our foundation is poured, and the team of specialists is on site. Now we're moving up to the main floors to find the engine room and the control center that keep the whole house running. This brings us to layer 3, the Android runtime, or ART for short. We can call this one the fast thinker. It is literally the brain of the whole operation, the system that actually understands and carries out the instructions that come from your apps. The process is actually pretty simple but incredibly powerful. ART grabs the code from an app, translates it into a language the phone's hardware can understand, and then it executes those commands. Think of it as the ultimate universal translator that turns an app's request into your phone's action. And what's so cool about this is that ART is not static. With every new version of Android, engineers are constantly fine-tuning it, making apps run faster and use less battery. This means your phone can literally get smarter and more efficient with just a simple software update. How cool is that? Moving one floor up, we find layer 4, the application framework. Think of this as the house's main control panel. It's this huge set of pre-built tools that app developers get to use, so they don't have to build common features from scratch for every single app. I mean, think about all the common things that apps do. Show you a screen, pop up a notification, or access your location. The application framework handles all of that. It's like a massive library of ready-made functions that developers can just plug into their apps, which makes building them so much faster and more consistent for all of us. So we've covered the foundation and all the internal systems. Now it's time to head to the top floor, the part of the house that you actually live in and interact with every single day. And here we are at the very top, layer 5, applications. These are the furnished rooms of our house, the games, the social media, the tools. This is the only layer you ever directly see and touch. And let's be honest, it's the whole reason we have smartphones in the first place. All your favorite apps, from YouTube to WhatsApp to that game you can't stop playing, they all live right here. They're written in modern programming languages like Kotlin, but they definitely don't work alone. They can only function because they are standing on the shoulders of those 4 incredibly powerful layers we just explored. So let's see it all in action. Let's say you want to take a photo.
You tap the camera icon, that's an application at layer 5. The camera interface pops up, thanks to the framework at layer 4. The app's code is then executed by the runtime at layer 3. The image processing is handled by the specialized libraries at layer 2. And finally, the physical camera sensor is activated by the kernel down at layer 1. 5 layers working together in perfect harmony, all in the blink of an eye. Amazing.
Okay, so we've seen how it all fits together. But that leads to the biggest question of all. Why? Why go to all this trouble to build Android this way? What's the big idea behind this whole layered design?
Well, the benefits are huge. By separating everything into layers, Android creates what's called a sandbox for each app, keeping it isolated and secure from the rest of the system. This specialization also makes the phone incredibly fast. And because developers have all these pre-built tools, they can create amazing apps way more easily. This flexible design is precisely why Android can power everything from your watch to your TV to your car.
And that idea of sandboxing is absolutely key to security. As one study puts it, this design does not allow applications to list the directory contents of other apps to keep the system safe. So in short, this layered house we've built is what allows Android to be secure, stable, and incredibly versatile all at the same time. So that's it, the 5-story house that powers billions of devices around the world. But as Android keeps expanding into everything from folding phones to our cars, you have to wonder, with AI becoming more and more integrated, will the next layer be less of a tool and more of a co-pilot living on a brand new floor of the house? Something to think about.